Hello, in this question we are given an electrical network and there is a fault on bus number 3. In the first part we have to calculate single phase to ground fault. This information is very important because there are three types of fault: single phase to ground and line to line and then double line to ground fault. All the three has the different formulas. So in this case we have single phase to ground fault at bus number 3. The second given thing is voltage of pre-fault is 1 at all the buses. We are given the Z bus of both positive, negative and zero sequence. D is for direct or positive sequence. I is for inverse or negative sequence, and 0 is for zero sequence. In the second part it's asking to compute again the currents of positive, negative and zero sequences respectively if the generator reactances are given and the transformer reactance is also given. So we will solve firstly the part A, single phase to ground fault. Guys, always remember that the formula for positive, negative and zero sequence currents is same for the single phase to ground fault. We have voltage pre-fault Z Thevenin of positive, Z Thevenin of negative, Z Thevenin of 0. All these three values are given in the Z bus. So we will take 3 cross 3 because the fault occurs at bus number 3. If the fault occurs at bus number 1, we will take 1 cross 1. If the fault occurs at bus number 2, we will if the fault occurs at bus number 1, we will take Z Thevenin 1 cross 1, first row, first column. If the fault is at bus number 2, second row, second column. But now in this case the fault is at bus number 3, so we will take 3 cross 3 in both cases. So putting the values, pre-fault it's already given that it's 1 at all the 4 buses. Now Z bus for positive, I mean D is 3 cross 3. So in this case it's 0.4 iota plus again 0.4 iota because it's the same. You can also write 2 cross 0.4 iota, it's up to you, plus now we will take some other now this is for the positive and negative, and this is for the zero sequence. So in this case we take 0.875 iota. Uh, 3 cross 3.875 iota. Okay, now by using the calculator you have to take care that it must be on the complex. For example, that is the complex mode number 2. Okay, 1 divide by bracket start 0.4 iota, what is for this one, plus 0.4 iota bracket close. So it is like minus 0.597 0 1 iota. So this is our first portion. We have calculated positive, negative and zero sequence currents, faulty currents, and that is equal to this one for the single phase to ground. For the other two options we have the different formulas for positive, negative and zero.